All right, page 54 in your textbooks. Page 54 in your textbooks. Let's take a look at your math homework from last night. You did numbers 1 through 24 in the homework section. We were practicing yesterday with adding and subtracting fractions. And the key to adding or subtracting fractions, class, you gotta have a
common denominator.
Common denominator. Same denominator means the same thing, but we usually call it common denominator because it sounds cool. So class, in order to add or subtract fractions, we have to have a
common denominator.
All right, so on number 1, do we have a common denominator, Michael?
No.
Michael.
Oh.
Number 1 in the homework, do we have a common denominator?
Sure.
Yeah, so we just add. Now, what do we add? Do we add the numerators, do we add the denominators, or do we add all of them? Just the numerators. What do I do with the denominator, Michael? Leave it as a 21, right? You keep 21, or 21st, all the way down. And so we added up. How many 21ths did you get?
I got
14 21st. But Michael did not leave 14 21st for his answer, did you, Michael? No, you changed it. What did you change it to?
I didn't leave it like that.
You didn't leave it as 14 over 21. Good.
Yeah.
What did you change it to?
I did.
Oh, you did? Oh, I was just sure you didn't. Kirsten.
2/3.
2/3. Kirsten saw that we could divide a 7 out of both because, class, we should always do what with our fractions? Reduce our fractions. So we'll take our 14 21st, reduce it down to 2/3. How many got 2/3 like Kirsten? How many left 14 21st like Michael? Okay, so you weren't alone, Michael. Number 2. Do we have a common denominator, Ben?
Yes.
Yes, we do. So we just add up all the fractions. Now, Ben, when we add up the fractions, initially, what do we get when we just add the fractions?
1/8.
No. I'm not asking you for the answer here. Just when you add the fractions. 3/8 plus 5/8 plus 1/8 gives you
9/8.
9/8. Initially, we get 9/8 for the fraction part of our answer. But Ben realized we don't want to leave that. So we changed it, Ben, or you did. And you said 8 goes into 9 once with
1 left over.
So you turned your 9/8 into 1, which went up with the whole numbers, and the 1/8. And then you added up all the whole numbers to get a final answer of
14
and
1/8.
14 and 1/8. How many have 14 and 1/8? Just like Ben. Number 3, do we have a common denominator? Elaine?
No.
No common denominator. We got to get a common denominator. And what was the denominator you went with?
18.
18. How many went with 18? That's the best one to use. Did anyone go with 36? All right, that could work as well, but 18 is the best one. So, Elaine, you had to change your 1/6 into how many 18s?
3.
3 18s. You multiply top and bottom by 3. Your 1/9 became,
2 18s.
and your 1/3 became,
6 18s.
and then you were able to add all of these together, and you got,
11 18s.
does that reduce?
No.
Is it improper?
No.
And we're done. I love it when it doesn't reduce and it's not improper. How many had 11 18s? Just like Elaine. Number 4, once again, we got to get that common denominator. So ignoring the whole numbers for now, Griffin, just focused on the fractions. What was your common denominator?
12.
12. How many used 12? How many went with 24? Anyone do 24? Nothing wrong with 24. 12 is the best one, though. So, Griffin, you changed 1/2 into how many 12s?
6 12.
Your 3/4 became,
9 12.
and your 5/6 became,
10 12.
as you multiply top and bottom by 6, by 3, and by 2. We ignore the original fractions. We just add these together. We get how many 12s?
25.
25. That's not okay, is it? How many times could the 12 go into the 25?
2.
Twice. So we're going to put that with the whole numbers. How many left over?
1.
Because 2 times 12 is 24, so there's only 1 extra of these. So we end up with a 1/12. And then when you add up all of that, we get, for our final answer,
32.
and 1/12. We get 32 and 1/12, our final answer. How many had 32 and 1/12? For number 4. Number 5, what'd you get for your answer? We'll go straight to the answer now. Paige, on 5?
38 and 1/3.
38 and 1/3. And number 6, Jalen.
29 and 23 48.
Excellent job. 29 and 23 40. So was anyone perfect on 1 through 6? You got all of the addition right. Are there any questions on 1 through 6? Yes, ma'am.
I got number 4 right, but I did 24 and I got the numerator of 50, and I still ended up with 32 and 112.
Yeah, absolutely. So if you went with 24ths, you'd have ended up with a 12 24ths, an 18 24ths, and a 20 24ths, which gives you, yes, 50 24ths. You're still going to get 2 and 2 24ths, which reduces back to the 2 and 112. The only difference is Griffin got to work with smaller numbers, and he didn't have to then reduce his fraction. It was already reduced 112. That's the benefit of going with what we call the least common denominator. But as long as you have a common denominator, it still works. So yeah, to your point, yeah, it doesn't have to be the 12. As long as it's something that's actually common, it's just because we're lazy, we'd like the smallest one possible. But whichever one you think of, if you look at those numbers like, I see 24, go with 24. Just good job remembering to reduce at the end. Great job there. Any other questions, 1 through 6? Well, let's take a look at some subtraction. Again, we have to have class A.
Common denominator.
At number 7, we got a common denominator. So we just subtract. And Corey, what do we get on number 7?
5 ninths.
5 ninths. Easy, easy. Number 8. Oh, we don't have a common denominator. Luciana, 12 and 10, what's the common denominator?
60.
60. Could you use 120? Sure. 60's better. What did you get for your answer, Luciana?
Maybe 60.
What is it?
Maybe over 60.
I think you added. I think you might have added. We had a 5 twelfths minus a 3 tenths. Let's first of all see what did you change these to. Your 5 twelfths became how many 60ths? 25 60ths. And your 3 tenths became how many 60ths? 18. Yep, you did. You said 43 60ths?
Yeah.
You were still stuck in add mode. We're subtracting. So if we subtract 25 minus 18, we get 7 60th. There we go. 7 60 is what we should have had. Be careful there. Number 9. We've got another problem where we've got to change to a common denominator. Number 9, Bryson, what was your common denominator? 8. So your 1/2 became what?
4.
4 eighths, right? And the 3 eighths was already good to go. So then you subtracted. You got what for your answer on number 9, Bryson?
5 and 1/8.
Oh, what's 13 minus 7? 6. 6 and 1/8. 6 and 1/8 is correct. Number 10, we ran into a little bit of difficulty. This is what we looked at right at the end of the hour. You didn't get a chance to practice this in class. I was hoping you would. We ran out of time. So I'm curious to see how we did on number 10. First of all, Sam, what was your common denominator? 30. How many used 30 for the common denominator? All of us should have seen that one pretty easily. Now, when you change to 30ths, 2/5 becomes how many 30ths, Sam? 12 30ths. And 5/6 becomes how many 30ths? 25. But here's the problem, class. Can we subtract 25 30ths from 12? No. So we've got to do what, Sam? No, we don't flip it. What are you talking about? No, we don't flip it. Okay, let me go back, Sam. If we had something like 32 minus 15, can you do 2 minus 5? No, so what do we do in that instance? We borrow. We borrow from the 3, make it a 2. We bring a 1 over here, make it a 12 minus 5, don't we? We're going to do the same thing here. When you can't subtract with fractions, you still borrow. So we borrow from the 24 and make it a 23. Here's the key, though. The 1 that you borrow doesn't stay written as a 1. It's got to be changed to a fraction. 1 as a fraction could be 3/3. It could be 8/8. It could be, Paige, 10 tenths. Griffin, it could be
30 30th.
30 30ths. Now, of all these up here, do any of those look like they could help us in this particular problem? The 30 30ths is the only one of those that actually helps, because here I have 30ths. So the 30 30ths comes to join forces with the 12 30ths. Kind of like the 10 that I borrowed joined forces with the 2 to give me a 12. Well, the 30 30ths, the one that I borrowed, joins forces with the 12 30ths to give me really how many total 30ths up here? 42 of them. Now we can subtract the 42 30ths minus the 25 30ths. And if you need to, off to the side, do the 42 minus 25. That's fine. How many 30ths do we get here, Sam? So 17 30ths. And then here we do this borrowing as well, and we get 2 minus 5? 8, and then 1 minus nothing. 1 minus nothing, 1, there we go. And so we end up with 18 and 17/30. Again, you didn't get a chance to practice this. So if, like Sam, maybe you struggled with this just a little bit, that's okay. How many did get it, just out of curiosity? How many got that answer? Okay, about half of you. Those who didn't, are there questions on number, whatever that was, 9? Questions on 9.
I thought that was 10.
Okay, how about 10? Any questions on 10? Smart Alex. All right, questions, I'm just seeing if you're paying attention. Good job. Questions on 10. All right, let's take a look at number 11. Once again, no common denominator. Once again, we've got to borrow, or excuse me, we've got to get that common denominator. What was the common denominator we went with, Michael? I'm sorry?
42.
You could use a 42, but there's a lot easier number than 42, Paige. 21 is going to be a lot easier. Now, nothing wrong with 42. Let's be clear. You can use a 42. But I feel like here the 21 is going to be the easier number to go with. Let me go back to Michael. Ignoring your work, let's just do it this way. If we used the 21, Michael, what would the new numerator become here? 14 21st. And then down here we would have
9.
And since we're subtracting, we just subtract 14 21st minus 9 21st. No borrowing needed this time. And 12 minus 6, of course, is... So how many had 6 and 5 21st? That went a little bit more straightforward because there was no borrowing involved. Then we come to number 12, and once again, we're going to have to do some borrowing. But first, we need a common denominator. And let's go to Kirsten. What's the common denominator here? 40. How many saw the 40? Should have. This one was pretty straightforward. All right, how many 40ths, Kirsten?
16.
And down here,
25.
can I subtract 25 40ths from 16 of them? It's not enough, is it? So I've got to, what's the term, class? Borrow. We're going to borrow from the 12, Kirsten, and make it an...
14. Oh, wait, no.
I'm going to borrow from the 12, make it... Oh, that's a 15. I can't copy. That's why you said 14. Okay, we're going to borrow from the 15, make it a 14. And the one that we're borrowing, I could write... It's all erased. I can write any way I want. But for this particular problem, class... You haven't paid attention up here. For this particular problem, how do I have to write the one that I'm borrowing, class? 40, 40. It's 40 over 40. It's got to be that way. No other way actually helps. So the total now, how many 40ths are up here, Kirsten? 56 40ths. Now I can subtract. 56 40ths minus 25 40ths. And again, if you need to, do this off to the side. I think we can see 6 minus 5 and 5 minus 3 right here. If you need to do it off to the side, that's fine. Kirsten, what do we get?
31.
Over 40. There we go. And then right here, when we subtract the whole numbers, we get 7. How many got, again, if you didn't, it's okay. How many got 7 and 31 40ths? Again, about half of you, again, those who didn't, you probably struggled with those two, number 10 and number 12. Do 10 and 12 make more sense now? Because we're going to be practicing more of this here in just a little bit. Questions on those? All right, let's take a look at some word problems here. Number 13, read that for us if you would, Ben.
Julie needed 3 3/4 cup of sugar to make her cheesecake. She checked the cupboard and found that she only had 1 1/8 cups. How many cups of sugar will she need to borrow from her neighbors so she can make the cheesecake?
And I hear stories of this all the time, and people go in next door to borrow a cup of sugar from their neighbor. I think I asked this before. I've never done that. I just go to the store and buy more sugar. Or like, well, I guess we're not making this recipe now. So anyway, but back in the day, people were more friendly. Anyway, what do we have to do to solve the problem here, Ben? She needs 3 3/4 cups. She only has 1 1/8. We subtract. So how many realized you needed to take what she needed minus what she had, and that tells how much she needs to borrow from the neighbor. How many subtracted here? Again, we need the common denominator, which is going to be class 8. Well, this is already an 8, so we don't need to change 1/8. 3/4 then became... What did you multiply 4 by to get 8?
6.
There we go, 6/8. So you multiply top and bottom by 2. And so we do 6/8 minus 1/8.
7 8.
Minus
5 8.
5/8. And of course 3 minus 1 is 2. How many have 2 and 5/8 cups of sugar for your answer? Good. Number 14, read that one for us, Elaine.
Joey can hold only 6 books at a time. If Joey had to remove 36 books, how many trips would Joey need to take?
Okay, so I'm picturing, for instance, I had my kids helping me this summer with all of the textbooks that you guys use. First, I had to go through all the Abeka boxes, check in all the inventory, make sure everything was here, make sure all the numbers were right. They only got 1 book wrong, which is great because I got of thousands of books we bought, only 1 book off. And but then I had to get them all upstairs. I'm like, I'm getting older, I got back problems, and I got free slave labor. So I got my two oldest kids. Now, they could not carry as many books as I could carry, but they could carry a few books. And after all, there's 2 of them making lots of trips. That helped me get the books moved. I still carried some as well, of course, but they could only maybe carry a few books. So let's suppose this Joey character, you're like, only 6 books, what a weakling. Maybe he's a little kid, okay? Cut him some slack. Maybe they're big books. But Joey can only carry 6 books at a time, and there's 36 books Joey needs to move. How many trips is it going to take? What do we have to do, Elaine?
Divide.
Divide, and we get
6.
6 trips. How many has 6 trips for the answer there? Questions on that? Let's look at the next page. Just some rounding problems. Number 15, when we round to the thousands place, what do we get, Bryson?
27,643,000.
That is correct. 27,643,000. Number 16, when we round to the hundreds place, what do we get? Jalen?
I got 11 million.
Number 16.
Oh, 16.
Round to the hundreds place.
9,500. No, 9,600.
9 million?
Huh?
On number 16?
Oh no.
Did you copy it wrong? You might have copied it wrong. Corey, take number 16 for.
9,578,000.
Good, the 2 isn't enough to bump the 0 up, so when we round to the hundreds, it kind of looks like we've rounded to the thousands, but 9,578,000 is correct. I'll come back to Jalen for rounding to the millions on number 17.
11 million.
Good job. 11 million is correct. Number 18, we had to divide by a power of 10. When we multiply or divide by powers of 10, which are numbers like 10, 100,000, 10,000, 100,000, million, stuff like that, class, all we got to do is move the decimal. If we multiply, the decimal goes to the right. And if we divide, the decimal goes to the left. And we just move it either based on how many zeros there are or based on the exponent. There we go, the exponent. In number 18, they wrote it with an exponent. So we're dividing by 10 squared. What do we get for number 18 page?
67.8544.
Excellent job. Number 19, what did you get when you multiplied by the 100, Sam?
9.84.
9.84. Number 20, when you multiplied by a 10 cubed, what did you get? Griffin?
1,005.
Well, not 1,005.
1,005.
1,005 is correct. Number 21, writing is a mixed number. What did you have, Jalen?
3 and 1/7.
3 1/7. Excellent job. By the way, that's going to be an important number for you throughout high school. 3 1/7, 22 sevenths. It's going to be an important number. You might not have learned it yet, but it's coming up later this year. Number 22. What is that as an improper fraction, Kirsten? 55/6. Number 23. They didn't actually change the fractions. They just wanted, what would the LCD be for 1/8 and 3/32? Bryson? 32. And what about the LCD for 1/5 and 1/6, Luciana? 30 is correct. Questions on the homework? Yes, sir. It is going to be important.
Is it pi?
It is approximately pi. How many have heard of pi? Not like, yeah, I've heard of apple pie. Like, pi like the number. Yeah, 22 sevenths or 3 1/7 is going to come up a little bit later on. Look across the page, if you would, at 454. Look at the review section. I want you to do number 70 to 77 in the review section at your seats. And then we'll get back to adding, subtracting fractions and mixed numbers, making sure we are good to go with common denominators and all of that stuff. Page 54, do the review 70 to 77. don't think the place is going to explode. If it does, hopefully we're all going to heaven. There's something out in the hallway. Oh well. Working quickly but accurately. When you finish, put your pencil down. Did you finish already? Did you work ahead?
Half of it I accidentally did yesterday.
Okay. Man, I was gonna give candy again today for it. That's why you looked at me funny when I assigned it. You're like, oh, oops, I think this was gonna be candy too. Oh well. All right. Michael finished? No, Bryson finished. Good. One more minute to work. See how many of these you can get done. And we'll take a look at them together. Nothing. All right, I know most of you haven't had time to finish all of them, but do need to keep it moving so we can get done with the lesson today. Give you a chance to practice some basic fraction stuff, particularly here at the beginning. Number 70, letter A, what was that first equivalent fraction, Sam? 8/14. How about letter B, what was the equivalent fraction? Paige?
5.
Well, the number is 5, so the fraction was 5/20. It's good. Number 71, when we reduce to lowest terms, Griffin. Letter A on number 71?
5/12.
5/12. And letter B, Elaine?
2/5.
2/5. Number 72, letter A, writing as an improper, writing as a mixed number or a whole number. Ben?
Number what?
72A?
I didn't get that
Did
one.
not get to that one, Jalen?
You didn't get to that one.
Did not get to that one, Bryson?
16 and 1/3.
Ooh, not 16 and 1/3, Luciana.
15 2/3.
15 and 2/3. The 3 goes into the 47 15 times. So real quick, the way you would check this, because I know some of you skipped it. How many times does 3 go into 4, class?
1.
Once. How many left over?
1.
How many times does 3 go into 17? Not quite 6. 6 would be 18, right? Doesn't quite go in 6 times, but it does go in 5 times. That'd be 15. So how many left over? 2, and the leftover goes over the original. There's our 15 and 2/3. How about letter B? Did you get that one, Ben?
Yes, sir.
What'd you get?
7.
7. It came out to a whole number. 73A, we were looking for the GCF and LCM for 12 and 16. Jalen, I don't know if you got that far, did you? 73A? Just looking at the numbers, what do you think the greatest common factor is? What do they both have in them?
Probably 6.
I'm sorry?
Probably 6.
Well, there is a 6 and 12. Does 6 times anything give 16, though? No.
3.
Well, there's 3 times anything give 16?
4.
4, there we go, because 4 is in both 12 and 16. So sometimes with smaller numbers, even if you don't do the prime factor, you can still figure out the GCF. What about the LCM, Luciana? Well, LCM, remember, is the smallest number they can become. So like 12, 24, 36, and so forth. 16, 32, so forth. So what would be that LCM, Corey?
48.
48. They can both become 48. And again, you would have the contest for the LCM, and you'd see what they share for the GCF. How about 18 and 45? What was your GCF? Did you get that far, Kirsten? What'd you get? 9. They both have a pair of 3s in their prime factors. Or you say, hey, those are both on our 9 times tables. 9 must be common. And then what about the LCM, Michael?
I forgot to do that.
Oh, I forgot to do the LCM, Elaine.
90.
90 is correct. If you take all the winners, you end up with a 90. Number 74. Show of hands, who got that far? I know we're getting into territory now where some of us didn't make it. 74. Let's go back to Kirsten. What'd you get?
1 and 112.
Excellent job. 1 and 112. Number 75. Even if you didn't get there, you could do it in your head right now, class.
3 7.
3 sevens. That was incredibly easy. Number 76. Show of hands who made it that far. Paige, what'd you get?
11 and 7, 15.
Great job. 11 and 7 15. And then 40 or 77. Also really easy, at least initially, Bryson. 10 15ths, but we didn't leave that. We changed it to 2/3. Great job. And it looked perfect on the ones you did. Even if you didn't do them all, of the ones you did, you got them. All right, any questions on the review? All right, I want to practice some more with the subtraction of fractions. Flip back to page 51. Flip back to page 51. And on pages 51 to 52, I want you to do numbers 14 to 24, the even numbered problems. 14 to 24, do the even numbered problems. Leave the odds for now. 14 to 24, even numbered problems. Gonna have to do maybe a little bit of borrowing in some cases. Gonna have to change to get common denominators. Let's practice, make sure we've got these down. Well, some of them are still addition, actually. There's some addition and some subtraction. There we go. A couple people finished already. We're just doing 14 to 24 units. Not too many rounds right now. 14 to 24 units. So you should pay attention to what you're assigned. posture there, sit up nice and tall, Ben. You're a tall guy, makes yourself extra tall. No, let me slide the rear end. There you go. Sit forward a little bit. There you go. Right, so one, and then the one comes up here, and then the 324 stays down here. Yep. Exactly right. Good, just work on the odds. Just another minute and a half or so. If you're already finished, most of you have told you this, but if you're watching on video and you're already finished with those evens, work on the odds. I'm going to be giving some answers to odd numbered problems here in a moment as well. So, but for now, we're focusing on those even numbers, 14 to 24. Something over 9, right? So it's got to be 9 over 9. It's going to be whatever over the same thing. So if we add on 9 more 9s to the 2 9s, we get, and now you can do the subtraction. Just give it a little longer to be finishing up those even numbered problems, or see if you can get done with the odd numbered problems. A couple of you already finished all the odds. You got some speed demons in here. If you're not a speed demon, that's okay, right? You do your best. Don't compare yourself to others. You do your best. But if you are a speed demon, push yourself.
You definitely are, Dad.
All right, for sake of time, pencils down. Even if you're not finished with all of these evens, let's take a look at them anyway. If you've been working on the odds, pencil down. We're going to take a look at those odds really quick as well. I want to start with the evens, though. Number 14, we're going to start by adding 3/4 plus 1/4. And class, what is that?
1/2.
It's 3/4 plus 1/4 gives us 4/4. But what is 4/4?
1.
It's 1. So there's no fraction left at all. We just carry the 1, add that to the 27 and 18, and we end up with a final answer, Sam, of? Number 14, what'd you get? 46 is correct. How many had 46? A whole number for your answer. Number 16, we did not have a common denominator. What was the common denominator that we needed to get here on number 16? Bryson? 24. So we should have changed it to 3/24. Check your work. 16 24ths and 8 24ths. Add all that together and we end up with 27 24ths. Well, that's too many. What do we need to change the 27 24ths into, Michael? Stay with me. What do we need to change the 27 24ths into? Which is? 1 and 3/24. So we'll carry the 1 up high, and then 1, 1, 1, 1 class gives us 4. But we're not going to leave 3/24 because class, we always have to reduce. And what do we get, Griffin?
1/8.
1/8, 4 and 1/8. How many had 4 and 1/8 for number 16? Number 18, we're trying to subtract. No big deal. We can do 7/12 minus 5/12, class.
4 and 2/12.
2 12s. And then the 23 minus 19, of course, gives us the 4 that we just got from Griffin. But we don't leave our answer as 4 and 2 12s. No. What do we change it to, Corey? 4 and 1 6. How many had 4 and 1 6 for number 18? Turning the page, number 20. Ooh, this is interesting. 4 minus 1 and 1/3. I have nothing to subtract a third from. So class, once again, I'm going to have to borrow. We'll borrow from the 4 class, make it a
3.
And the one that I borrow could be written any way I want as long as the top and bottom match. But this problem, how does the one need to be written, Paige?
3/3.
3/3. And now I can subtract 3/3 minus 1/3 class.
2,000.
And of course 3 minus 1 is
2.
And how many had 2 and 2/3 for number 20? Looking at number 22. Oh, we don't have a common denominator. What do we change 1/3 to? Luciana? So we'll make this 3 and 2 6 minus 2 and 1 6. And hey, I don't need to borrow for this class. 2 6 minus 1 6.
1 6.
And 3 minus 2?
1.
So 1 and 1 6. How many have that for number 22? And number 24, give myself a little bit of space here. What was the common denominator we needed on 24? Ben?
I didn't get to that.
Well, let's do it now then. What's the common denominator, Ben?
9.
9. Now the top already has the 9, so I don't need to worry about that, but the bottom needs to change. 1/3 becomes, how many ninths?
39.
3 ninths. But can I subtract 3 ninths from 2 ninths, class?
No.
No, so I have to borrow from the 37 class, make it a 36. And the one that I borrow, Ben, has to be rewritten how?
9/9.
9 ninths. Now I already had 2 ninths, so I'm going to add the 9 ninths to the already existent 2 ninths to get how many total ninths?
11/9.
11 ninths. Now I can subtract, Ben, 11 ninths minus 3 ninths?
8/9.
8 ninths, there we go. 36 minus 16, well of course 6 minus 6 is
0.
and then 3 minus 1 is
2.
2, so 20 and 8 ninths. How many had 20 and 8 ninths for number 24? Are there any questions on those evens first of all? Any questions on the evens? All right, we're going to look at the odds very quickly. Now listen, if you did not do the odd problem, if you did not do a particular odd problem, as I'm giving the answer, look at the problem and still think about it. Keep your brain engaged. Don't turn your brain off. And think, would I have known how to do this? And if you're like, yeah, I think I would have known how. I'd have been fine. I didn't have time to do it or I didn't get to it, but I'd have been fine. Great. But if you feel like, if I saw that on a quiz or test, I'd have been scared. Then raise your hand and ask at the end. All right, so I'm going to give all the answers to 1 through 25, the odd. You check your answers and or check if you would have known how to do it. Number 1 is 4/8, which becomes a half. 1/2 for number 1. Number 3, 1/5. 1/5. Number 5 is 1 and 5 ninths. 1 and 5 ninths. Number 7 is 1. 1. Number 9, 2 ninths. 2 ninths. Number 11 is 11 twelfths. 11 twelfths. Number 13, 1 and 7 thirtieths. 1 and 7 thirtieths. Number 15 is 20 and 5 eighths. 20 and 5 eighths. Number 17 is 3 and 1/5. We reduce the 4 20ths. 3 and 1/5. Number 19 is 1/3. 1/3. Turning the page, number 21. You have to do a little borrowing there to get 1 and 1/3. Number 23, 5 and 3/8. 5 and 3/8. And number 25 is 2 and 9/14. 2 and 9/14. How many, all the odds you did, however many that was, you got them all right. All the odds you did were right. All right, are there any odds that we need to see worked? Any odds we need to see worked? Page?
11.
Number 11. Let's take a look at 11 real quick. So we had 7/4 minus 5/6. Whoa, 7/4. Wow, they did an improper fraction. How about that? All right, so 7/4 minus 5/6. Here, Paige, we can't do the subtraction yet because we don't have a, and the common denominator of 4 and 6 is, it could be. Anyone think of something better than 24? Call it 12. But 24 works, so I'm just going to go with the 24 that Paige said because that's fine. No problem with it. Here, how many 24s?
20.
And here, how many 24s? Well, you're multiplying by 6, so we get
42.
42. When we subtract 42 minus 20, it gives us 22, of course, over the 24, and then we divide out the 2 to get the 11 twelfths for our answer. Does that make sense? All right, good. Other questions on the odds? Any other odds we need to see worked? All right. Let's look next at word problem number 20. Actually, I'm going to save those. I'm going to save that rather for tomorrow. Let's go on to multiplying fractions. Multiplying fraction. You see this on page 48. Page 48 at the bottom of the page. I'm already getting a little bit of a yes from Ben because I think Ben remembers a couple things about multiplying fractions. First of all, it's easier to multiply fractions than it is to add them because, write this in the side margin of your book, you don't need a common denominator. All that common denominator nonsense we were having to do, you don't got to worry about when you multiply fractions, and that's happy because that saves work, which is great because we are lazy. We don't want to do more work. Okay? So you don't need a common denominator. All you got to do, write this down, is you multiply the top, multiply the bottom. If you want to sound more mathy about it, you multiply the numerators and multiply the denominators. You multiply the top and you multiply the bottom. Sound good? So for instance, if we had 1/5 times 2/3, I multiply the top, class. 1 times 2 is?
2.
And then I multiply the bottom. 5 times 3 is?
15.
And we're done. It's easy. We love multiplying fractions. Now, what if I saw something like this, though? 5 times 2 sevens. Well, wait a second. That is not a fraction. If it's not a fraction, class, put it over 1. Do you remember this? Anyone say, I've never seen that before. Okay, good. All this is, I tricked you that time. All right, so again, we multiply across the top, class. 5 times 2 is?
10.
And 1 times 7 is?
7.
And we're not done this time. Why aren't we done this time, class?
We have to
It's improper. We can't leave an improper fraction. But we're good at this. Class 7 goes into 10.
1.
We got any left over?
3.
3. So we get 1 and 3 sevens. And now we're done. It's still easy, right? We like easy.
Yes.
What about something like this? 3/5 times 3 1/2. Write this in the side note margin. You cannot multiply mixed numbers. You have to make them improper. So we're on page 48, Page 48. You're writing this on the side margin next to where it says multiplying fractions. You have to have improper fractions, never mixed numbers. Mixed numbers are no-go. You can add and subtract mixed numbers, but you cannot multiply them. So 3 1/2 is no-go, right? The 3/5 we're cool with. The 3 1/2, not so much. What does 3 1/2 have to become, Corey?
7/2.
7/2. And now, class, we multiply the top. 3 times 7 is?
21.
And we multiply the bottom. 5 times 2 is?
10.
And we're not done. But, class, 10 goes into 21. 2 times with?
1.
And now we're done. So it's still not that bad. We like multiplying fractions because it's easy, okay? Write this down, though. 6/20 times 5/9. We multiply across the top, class. 6 times 5 is? 30. And 20 times, well, that's actually not too bad. What's 2 times 9?
18.
And let's stick a 0 on the back. 108. And now we got to reduce, right? So we can knock off the zeros together. That's dividing by 10. And then 3/18 reduces to 1/6. But you know already, there's a better way, Ben.
Cross out the 6 and cross out the 9, and for the 6, add 2, and for the 9, add 3.
What's he talking about, class? He's talking about canceling. You could, if you wanted to, multiply the top, multiply the bottom, and then reduce at the end. But you're going to have big numbers. Are we fans of big numbers? No, because we are lazy. Avoid big numbers by using cancellation. We're not going to just multiply across the top, multiply across the bottom, and then reduce if we can help it. If I see something like, hey, 6 and 9, what is inside both 6 and 9 that can come out, class?
3.
A 3. And I take a 3 out of a 6, I get 2. 2. Take a 3 out of a 9, I get 3. But there's more canceling that can be done. What else could we cancel, Kirsten? The 5 and the 20 to get what?
4. Oh, wait.
4 on the bottom and
And 1.
1 at the top, because you took out a 5. There's actually still more canceling we can do. Corey? Page?
2/12.
Well, I don't have a 12 yet. The 2 and the 4. Any numerator with any denominator, including straight up and down. That's just basic reduction. 2 and 4 could cancel to give me what? Whoever said it a second ago?
1/2.
1 and 2. And now that we've canceled everything we can, we've got a really small little multiplication problem. We like small multiplication problems. Class, 1 times 1 is?
1.
And 2 times 3 is?
6.
It's the same answer we got a minute ago, but we got it without having to deal with big numbers. Write this down. 1 and 2/3 times 4 and 1/2. What did I say about mixed numbers, class? Can't multiply them. You've got to make them improper. Jalen, what is this as an improper fraction?
5/3.
Good. And what is this as an improper fraction, Griffin?
9.
9 twos. 9 halves. Yes, 9/2. And then I could multiply across the top. Multiply. I don't want to. If there's something I can cancel. There's only one thing this time that cancels. What is it, Paige?
3 and 9.
The 3 and 9 to get.
1 and 3.
And now we multiply across the top, Sam.
15.
And we multiply across the bottom. 2. And we don't leave our improper fraction class. We say 2 goes into 15. 7 times with
1/2.
1 left over, so we get 7.5. Do we remember all of this from elementary school? Any questions on multiplying fractions? Page 52. I want you to do 29 to 35, the odd numbered problems. 29 to 35, the odd numbered problems as we finish out today. Some people already finished. Quietly finish.
Is it wrong to do like multiply and then divide?
You could do that and then reduce. You could just multiply. You don't have to do the canceling. It's just you deal with really big numbers if you don't.
I find it easier to just divide.
It is up to you. It's up to you. You don't have to do it. I look for shortcuts anywhere I can get them. And to me, making the problem little instead of big is a huge win. But you don't have to. As long as you get the same answer we give here in just a minute. Question? Now you just multiply. Right? So you go 3 times 3 is, and what 2 times 1 is, make it that into 1. And then you make it back into a mixed number. That's all. All right, let's take a look at the answers here. Number 29. What could you cancel if you wanted to, class?
2.
The 2's. What did you get for your answer on 29? Kirsten?
1/5.
1/5. Number 31. What could you cancel if you wanted to, Sam?
39.
To get a 1 and 3. What was your answer, Sam?
1.
Careful. What's 5 times 2 15ths? There we go. 2 15ths is our answer. Number 33, class. Before you can do the problem, you've got to put the 4 over 1. And then, could I cancel the 4 and the 6, class?
No.
Why not?
Oh, yes.
No, because they're both numerators. So watch, as long as it's a numerator, I can cancel with either denominator. It doesn't have to be diagonally. As long as it's a denominator and a numerator, I can cancel. But you never cancel 2 numerators with each other, and you never cancel 2 denominators. So is there anything that cancels, class?
No.
So we just have to multiply across to get 24 7ths, but we don't leave 24 7ths. We change it, Corey. 3 and 3 7ths. And number 35. Once again, class, we've got to put the 12 over 1. Can I cancel the 12 and the 3, class?
No.
No. But I can cancel the 12 and the 8. And then what can come out of 12 and 8, class?
Two.
I could take a 2. I could do better. I could take out a 4, couldn't I? Take out a 4 to get?
2,
Take out a 4 to get?
3,
I can't cancel the 3s? No, we have to multiply. Class 3 times 3 is?
9,
9 over the 2 gives us what for our final answer here, Jalen?
4 and 1/2.
4.5 is correct. How many got all 4 of those correct? I will practice with more of that tomorrow. No homework this evening. Have a wonderful rest of your day, and you are dismissed.